All right, welcome back. This is the Module 2, which is the bath bomb, Checkpoint 1 study guide. Today is Wednesday, our quiz is going to be on Friday, and let's jump right into it. So, mixtures versus compounds, right? A mixture can be physically separated. When we put salt in water, we can run it through a filter and get the salt out. When we have water itself, we can't so much get the molecules apart without doing something chemical. So today in class, we ran electricity through water and we broke it down chemically, which is much harder to do, right? So mixtures separated physically. So M&Ms and Skittles, if I pour them in a bowl together, you can easily pick one out or the other. Or over here, your H2 and your O2. Obviously, they're not connected, they're not touching, they're individual, and here's some vocabulary for you, individual, diatomic, two atom, elemental, two atoms of the same element, diatomic, elemental, molecules. That means they're connected. It's a lot of words, diatomic, two, atomic, atom, elemental, same element, molecule, attached, diatomic elemental molecule. I know that's a lot. The same thing for hydrogen, it is a diatomic elemental molecule, but since they are not connected to each other, you can see the hydrogen is not connected to the oxygen. They would be easy to separate. If I let them out of this container, the hydrogen would float off and the oxygen would sink. Fairly simple. Compounds. They have to be separated chemically. So water molecules over here, H2O, you saw in class what happened when we had to break them apart. We were running 81 volts through the water, and we were, breaking the hydrogens and oxygens off and pulling them over, and you saw corrosion and oxidation of the positive lead. So you saw oxidation from the oxygen of the positive lead. We were getting a chemical reaction. The same thing when we did elephant's toothpaste. With elephant's toothpaste, we had H2O2, and we broke off one of the oxygens. So it was, again, a chemical reaction, not something that's easy to do. You have to somehow come in here and chemically break these bonds, holding those atoms together. So, I feel like we've talked about this for about 3 weeks. Mixtures can be separated physically. Can it be separated physically? All matter. Can it be separated physically? Yes, it's a mixture. No, it's a pure substance. So, an element is a pure substance that cannot be broken down further by physical or chemical means. So an element would be something like H2, that is elemental. I can break that down into H and H into two hydrogens, but I cannot break hydrogen down. I cannot break this hydrogen down anymore. That hydrogen is as small as it gets. This is where the law of conservation comes into play. The law of conservation says I cannot destroy that atom. I can break the H2 down into its root parts. In this case, the atom of hydrogen, but the elements, even though there's two of them, it would look like this up here, even though it would be two of them, cannot be broken down into other substances by chemical or physical means. I can take them apart, I can have two hydrogens, but just cannot break the hydrogen down into quarks. There's a whole different set of science for that. So be familiar with this graph, with this flow chart. Matter can be separated. Yes, it's a mixture. No, it's pure substance. Mixtures, furthermore, if it is all looking the same, homogeneous, it's all looks the same, it's homogeneous. If you can tell the parts are different, heterogeneous. If you can tell the parts, what they are, salad dressing, like Italian salad dressing, you can see it's different. soil, you can see rocks, you can see dirt, you might see a worm. You can tell it's different, then it's heterogeneous. Over here with pure substances. Can it be decomposed by ordinary chemical means? Yes, I can break H2O down into H and O. I can break sugar down into CHO. I can break carbon dioxide down into CO. Can you break it down? Is there more than one different type of atom present? Yes. Compound. No. Something like O2, H2, Ne. That one doesn't bond to anything. It's a noble gas. Noble gas don't bond. So if it's only one element, one type of atom, element. So let's define some of these words. What is an atom? An atom is the basic building block of matter. So atom is the basic building block of matter. It is the smallest part of matter we're going to talk about. In classical chemistry, this is the smallest part of matter we're going to talk about. What is an element? An element is two or more of the same, I can't talk and write at the same time, of the same type of atom together. So if I have a box and that box is full of the same type of atom, that is element. Okay, so that is element. Even if that was O2 and it was all oxygen, but it was in the same box because oxygen wants to bond to itself. Element. A mixture. What is a mixture? We've beaten this horse. What is a mixture? Two or more, and I'm just going to say things, two or more things that are not chemically, that's the important part, combined. That's not how you spell combined. I don't know what I was writing. Two or more things that are not chemically combined. Salt and water. The Skittles and M&Ms, which I always go back to, right? My Crystal Light and my water. Not chemically combined. You can either see a difference or you can't see a difference, but either way, they are separatable by physical processes. A pure substance. Dead giveaway right here. What am I about to say? It has what am I about to say, guys? It has a chemical formula. A pure substance has to be able to be represented by a single chemical formula. You can't represent milk, even though it looks like it should be a pure substance. Homogeneous mixture is milk. It does not have a chemical formula. Water, H2O, has a chemical formula. If it has a chemical formula, it is a pure substance. Has a chemical formula. That means only a chemical reaction. Whoops, the light's turned off. Only a chemical reaction can separate it. I'm running out of room. SE. Only a chemical action can separate it. Let me pause this and go turn the lights back on. I'll be right back. Sorry, I had to get up. I have all the chairs on the desk since it's 7th period, and the light sensor doesn't see me over here. So, anyway, where were we? Oh yeah, only a chemical reaction can separate a pure substance. So to get the water apart, chemical reaction. To get the hydrogen peroxide apart for the elephant's toothpaste, chemical reaction. The citric acid and baking soda to make the CO2, chemical reaction. I have to have a chemical reaction to get it to come apart. A compound is, and when we say compound, compound is short for compound molecule. So we use this, and I said we use them kind of interchangeably. Compound is short for compound molecule, so a lot of times you'll hear compound, and we are referring to things up here. A compound is two or more different, two or more different elements bonded together. We can kind of take this back to study guide 1 where we talked about compound molecules and elemental molecules. So an elemental molecule is something you're seeing up here. O2, H2, those are elemental molecules. These are elemental molecules, the same element bonded together. A compound molecule is two or more different elements bonded together. So I have H and O here. That would be a compound. And ignore the word mixture for a second. This is an elemental molecule because it's the same element. And you can always, this is neat, you can have a mixture of different kinds of compound molecules or elemental molecules. You can have a mixture of compounds and atoms. You could, over here, even have just a single atom or two floating around. And that would still be a mixture of a compound and atoms, right? So, when we say compound, it's short for compound molecule, two or more different elements bonded together. Okay. We have talked about this almost zero, but you have talked about this over the last few years. A physical property is the stuff you can see, feel, touch. A chemical property has to do with the underlying elements. So, physical, same stuff, different form. If I have a broomstick and I break it into 500 pieces, still a broomstick, just in 500 pieces. If I have a broomstick and I set it on fire, now I have ash and smoke and carbon dioxide, and things have happened. It is new stuff. Does that make sense? So when I look at these, physical property, color blue, is it physical or chemical? Yeah, physical property. Density, physical or chemical? We did a density lab. I hope you know. Physical property. Flammability. Chemical property. Sorry guys, I keep pausing this because I keep coughing. And I don't want to just sit here and cough on your video, right? Excuse me. Okay. Oh man. Solubility, the ability to dissolve in water. When you dissolve, are you making a mixture or are you making a compound? Salt dissolves in water and makes a mixture. So solubility, physical. Reacts with acid to form H2. H2 is hydrogen. Yeah, reacts, definitely chemical. That's a giveaway word. Supports combustion, supports burning. Yeah, chemical. Sour taste. Now, while the neurotransmitters in your tongue may be saying or sending chemical messages, the taste is a physical property. Melting point. Changing from ice to water or liquid water, liquid physical property. Reacts with water to form a gas. There's that word again. Reacts with water to form a gas. Chemical property. Reacts, do I need to read the rest of it? Reacts with water, period. Chemical property. Hardness. How hard it is. A diamond is a 10. a diamond's a 10, sapphires are 9s. So hardness, it's a physical property, how hard it is. Boiling point. If you're thinking melting point was physical, it's a good idea to think boiling point was physical. Breaks easily. Another word we use for this. It's brittle. It breaks easily. Yeah. Physical property. If I can just crumble it up, that's physical. I never changed what it is. Is magnetic. Is magnetic. Physical property. I thought I was going to trick you there. Good conductor of heat and electricity. Today you saw the copper wire was a good conductor of electricity. Is that a chemical property or a physical property? Yeah, it's a physical property. It allows things to transmit through it. Give an example of a physical property you have seen in class. I mean, we've seen quite a bit. I knock on the desk a lot and tell you it's hard. So physical property. Desks are hard. Give an example of a chemical property you've seen in class. The one that I think we were successful with in every class. Oxygen supports combustion. So when we released that oxygen in the elephant's toothpaste, we saw that it supported combustion. Kinetic theory of matter and phase changes. So, as we add heat to a solid, we add energy. Temperature is a measure, like we took in our notes, a temperature is a measure of average kinetic energy. We turn a solid to a liquid. As we add more heat, we can turn a liquid to a gas. As heat leaves the system, remember, we don't want to say we remove heat, but as heat leaves the system, a gas becomes a liquid, and a liquid can become a solid. And you can see the movement of the particles. These gas particles are free to move. They have escaped each other's something. It's down here. They have escaped something. The liquid has not escaped, but has the ability to slide around each other. In the solid, they vibrate in place, have a definite shape. This should all be on your notes from the states of matter notes we did like last week. So, describe particle motion of 3 phases of matter. Particle motion. Vibrates in place slowly. Vibrates in place slowly. So this is obviously talking about the particles, the individual atoms. I guess it could technically be the individual compounds or whatever. But the individual pieces at the molecular level are vibrating slowly, not moving very fast. Liquids, they can slide past each other. They slide past and have more movement. Oops, my R. So up here, you can see the liquid. They have more movement. I mean, vibrating, but these are actually able to pass. Excuse me. This is why I've been pulsing. The gas is pretty much free to go. The gas has a lot of energy, and it's free to move wherever its little gas heart wants to take it. Because gas has done something special. It has enough energy, enough average kinetic force, enough temperature for its size and weight, that the force, this is fun, the force that holds the molecules together has been overcome. And we call that force the intermolecular force. So the force that holds molecules together, intermolecules, molecular force. The intermolecular force has been overcome by the gas, and the particles are free to move around. Dun, 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 dun. It is driving me crazy that this is on the wrong page. Let me look. Yeah. Okay. I need to add one space next time to get the line down. Okay. So label the phase changes. Here is your key. So let's just start at the top. Freezing. Water, liquid to solid, water in this case, freezing. Okay, we got freezing, check. Sublimating, think dry ice. Solid, straight to gas. Sublimating. Condensating. What is condensating? Think your windows right now when you get in the car or on the bus in the morning. Condensating. Sorry, I have to turn the paper for this one. I'm sorry, guys. I have this silly cough. Condensating. Gas to a liquid. Perfect. Evaporating. We call this vaporization. We call this boiling if you're adding heat, but evaporating is just the top layer. You should have seen that in your Ed puzzle when you did that. So evaporating is liquid to a gas. Evaporating, liquid to a gas. Deposition. I don't know how to put an "ing" on that. So depositioning, I think that happens in court. So that is when we go straight from a gas to a solid with no liquid phase. Deposition, perfect. And then melting. I think we're all familiar with melting, like the snow does in the winter, so we get to come back to school. Yay! Melting from a solid to a liquid. Good. So the next instruction, draw the following pure substance and mixtures. Awesome. Wish I would have spaced down a little more. Sorry about that. So draw a compound molecule. So I'll do a couple. Obviously, this is water. But if I wanted to do, I'm not sure if that's the right shape, but we'll call this hydrogen peroxide. Two or more different atoms, different types of atom, HO, bonded together. So we could also do something like this, and that might represent CO2. What else could we do? Maybe you see something like this. And I mean, this could be water again, H2O. I doubt you'll see anything different than these things, but yeah, this is different ways you can represent a compound molecule. Elemental molecule. The same element two or more times. So you might have OO, that could be O2, could be H2, could be anything. You might have OO, you might have triangles. What could that be? S4 maybe? S4. SH4, so sulfur. So, I'm so silly. I was just thinking of drawing different things. Yeah, elemental. It is, sorry, ignore that one. It is the same element more than one time. O2, S4, H2, it could be H2 down here. So draw a homogeneous, everything looks the same, mixture. homogeneous mixture. How could you draw that? I mean, I'll do one in this box, like right here. Everything looks the same in that box. Or I could write so in that box I have a mixture with hydrogen and water completely mixed together in the same proportions, 3H2O, 3H2. That should be a homogeneous mixture. It is the same throughout. So heterogeneous mixture. I might have something like this. Very disbalanced, very unproportional. I have 6 O's and 2 triangles. That is definitely different. Pretty simple. I might have squiggly line, dot, 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 X, X. Obviously, that does not look the same throughout. There are differences there. Maybe that's a salad. I'm not sure. But that is different, heterogeneous mixture. The law of conservation of matter. I'm moving quickly over this. We did an entire study guide basically over that. So I think you all pretty familiar, but definitely it shows up Friday. Be aware. Law of conservation of matter. Oops, I got to go to a detail. I'll be right back. So, sorry about that, guys. I did not realize we were that close to the bell, and I had a after-school duty I had to run and attend to. But we are back, and remember, do better than me. Elemental molecule, same element more than once. Don't do that one. Law of conservation of matter. Okay. I have calcium, 64 grams. I have zinc carbonate, 192 grams, so 64 plus 192, 6, 15, 256. Okay, so over here, now I have made a reaction. Calcium reacts with zinc carbonate and produces or yields calcium carbonate. And I had 256 grams total, 256 grams total going in. And I know now 152 of those are the calcium carbonate, so I can just subtract 0, 1. So I know that I have to have 104, that's a 4, 104 grams of zinc. So pretty simple. This added to that, so this add this, 256 yields this, take my 256, subtract that out, 104, so I have 104 grams of zinc. Also, law of conservation of matter. You might see, let me just scroll down here. Scroll, golly, you can tell I use the computer too much. You might see something like 2 water molecules separates. So this would be 2H2O, coefficient, 2H2O. So 4 hydrogen, 2 oxygen, because remember, this is a multiplier, yields decomposition reaction. I get over here, and I have my 2 oxygen combined together, and then I have H2 twice. So everything that was over here is also over here. Okay, something like this, 2H2O. So let's go ahead and list all of the elements, H's and O's. I have 4 H's and I have 2 O's. So come over here, O2, sorry about that, I started to write that first. So let's list them all. I have O, I have H, I have O twice, I have H2 times 2 is 4. So I can prove out that reaction there. You may see something like that, where if you go back in your mind to when we were counting how many elements or atoms, or elements broke down into different atoms, how many atoms of each thing, like today in the warm-up, we talked about how many atoms of hydrogen, how many atoms of oxygen in a molecule. And if you had a coefficient of 10, how many you would have then. Excuse me. So it's the same thing. We'll list them out, and we will do more of this. You're going to get tired of doing this. But we are just proving that this equation is balanced. So restate the law of conservation of matter. Matter can not be created or destroyed. Hang on, my eyes itching. Destroyed. Matter cannot be created or destroyed. And when we talk about matter, we're not talking about the molecules. We're talking about the atoms. Like today, we broke apart the water molecule into hydrogen and oxygen. When we broke the molecule apart into the atoms. The atoms cannot be created or destroyed under normal chemical rules, under normal chemistry conditions. We can't get into atomic stuff and disprove this. Well, hang on. I'm going to quit talking. I shouldn't say disprove. We can get into atomic. We can add energy into the equation and get a lot of fun stuff going on. But that's what we have. I will post a copy of this. I'll go scan it in just a minute and post a copy of this. I'll put this video on YouTube so you can see my mistakes as I worked through it. And I wish you all the best of luck.